basically, today we'll talk about marine energy in general, so globally, and also marine energy and its potential relevance for New Zealand, because basically this is maybe the most important point why this thing can be relevant for New Zealand, and why should we actually bother to think about marine energy in New Zealand. So first of all, I would like to give credit to Martin Nock, who is the co-chair of New Zealand Marine Energy Association. So actually, I would say that he has done most of the job with preparing these slides. So he is very good in making presentations, but he is not academic. He is just an entrepreneur who believes in marine energy, because basically he sees some investment and business opportunity in developing marine energy in New Zealand. So he has done most of the job with preparing the slides. So I just wanted to give credit to him. Okay, so how much time do I have? Do I have around 20 minutes, right? I have around 20 minutes just to make sure that I'm on time. So is it 20 minutes?
You take the time that you need, Vladislav, that's fine.
Okay, so basically the plan is that I will briefly talk about marine energy in general and related to New Zealand, and then also very briefly talk about my own like research of my group at the University of Auckland in this space. Yes, so basically, if we talk about marine energy, then you can talk about marine energy even to people, even to school children, and they actually understand that there is a lot of potential in marine energy, simply because power potential of, let's say, waves is something that we can see if we just go to, I don't know, if we go to Piha. So obviously there is a lot of power potential in waves and also in tidal energy. And for example, power density of marine energy is 10 times more than power density of wind energy. So there is a lot of energy in marine resources, and the only thing is how to actually get this energy out, how to extract this energy. So then also if we compare, let's say, wave energy, so only part, so first of all, I would like to say, I will talk about it in a couple of minutes from now, but obviously marine energy includes not only wave energy, but also tidal energy and other types of energy. But if we consider only wave energy and just compare it with wind and solar energy, then what we immediately see, what is the main advantage if we compare marine, like this wave energy, as comparing to, let's say, wind and solar? And actually it's obvious that unfortunately, if we consider wind and solar, then we see that unfortunately it can actually, like, let's say if we consider only wind, then it provides some let's say sufficient amount of energy, or some reasonable amount of energy, only during some certain periods of time. If we consider, let's say, day, what is happening within 24 hours, then let's say it works for 2 hours here, 2 hours here, 2 hours here, and then it doesn't work, doesn't provide any energy. Actually, similar thing is with solar. Obviously, during night we don't get anything, but during day we get a bit of energy out. But wave energy, let's say, or tidal energy, it actually works almost all 24 hours. So it's very consistent. So it doesn't have this kind of variations with day. And also, if we consider times of a year, then obviously during autumn, let's say, and winter, we get a bit more wind here in New Zealand. But waves, they are okay. In winter, probably we get a bit more, but comparing to summer, the difference is not that strong. So basically, one of the main advantages of marine energy comparing to wind and solar is that it's actually very consistent. And also, of course, the main advantage probably is that think about the power potential. So a lot of power potential. And so maybe we can do something like this. Maybe we can combine wind energy with wave energy, or maybe wind energy and tidal energy. And already this kind of ideas already they try to develop prototypes. In Australia, for example, they try to harvest combined wave and wind, and we actually get 90% energy production. So not 20% as only for wind, but 90%. And this is actually pretty impressive. I cannot leave this slide out. So this is an important slide. So obviously everyone is concerned about climate change. So we need to do something with this climate change, and take into account the government position. We need to maybe try to use some ocean-based solutions to mitigate with climate change and reduce our greenhouse gas emissions. And actually, ocean seems to provide a lot of opportunity here. So, like, if we aim that we want to reduce by 2050, we aim to reduce this. This is something that was announced by this global climate is it committee or something? So we have to reduce 56 gigatons of this CO2 emissions by 2050. Then simply if we use a bit of our brains and we try to use a bit of opportunities which are provided by ocean, then we can actually get 11.8%. We can get 11.8 gigatons of this CO2 simply if we use ocean. And actually, renewable energy, ocean-based renewable energy, gives us this like 5.4 gigatons of CO2 annual reductions of emissions. So this is actually kind of impressive. So maybe the numbers are not that important, but there is a message. So the message is actually that, again, if we talk about climate change, then maybe we can just take a look at the ocean and see how it can help us to mitigate this climate change. Okay. Okay, so basically, typically when people start to talk about marine energy and wave energy or tidal energy, then maybe the first impression is that, okay, so maybe we're talking about something big. So maybe we want to harvest a lot of energy, we want to harvest a lot of, we want to provide utility scale energy. But actually, there are many use cases, many niche applications in which this marine energy can be kind of helpful. So the obvious example is trying to use marine energy for, let's say, powering buoys which try to do some ocean observation and ocean monitoring. And actually, this is what my work, my group at the University of Auckland is doing. So we try to use wave energy for powering smart buoys that do this ocean monitoring. But then there are also other options. So how about, for example, that we just try to power aqua farms? So we obviously, like, there are many aqua farms around New Zealand, and aqua farming industry is growing very fast in New Zealand. And actually, energy demand is kind of significant for aqua farming industry. And unfortunately, my collaborators in this field, they say that, I mean, real aqua farming companies, they say that unfortunately we need to pay a lot of money for this, for energy. So they actually pay even more than here in Auckland for 1 kilowatt hour. So how about what we try to use a bit of, let's say, tidal energy to supply power for the aqua farms? So maybe this is something that we can try to think of. And then also, of course, something which is very relevant for New Zealand is trying to provide power to some coastal communities. So maybe it's actually more relevant for Pacific Islands, like, let's say, Samoa or Fiji or Tonga. But actually, maybe this is another use case where we don't need too much power, but we can actually provide the power which is required, which is needed. And there are also other different things, like for example, these blue data centers, when we try to put them underwater and try to provide some power for them, like blue transport, these kind of things. So actually, it seems that there is a lot of potential use cases of marine energy, and basically the total market for this marine energy is actually very, very strong, very, very large. So it's 800 billions of US dollars. So a lot of market is quite kind of significant. And then maybe just one slide on why marine energy. So why we talk about marine energy for New Zealand. So actually marine energy can help with creating new jobs. Also, as I said, mitigate climate change. Then it also can provide this kind of interesting idea about trying to combine generation of power with water desalination. So this again may be useful for remote islands, remote Pacific islands. Then also like ideal to couple with our renewable energies like wind. So maybe we can combine with wave and tidal with wind. And basically, again, as I said, marine energy is very well predictable. And basically, it offers a lot of capacity. It has a lot of power in it. So basically, marine energy has something in it. So it can actually provide something for New Zealand. And basically, the only thing is that how to extract this energy from the ocean. And this is something that I will talk in a minute. So the first thing, if we talk about ocean technologies, is actually that we maybe need to talk about the technology readiness levels. So there are there are many technologies that try to extract marine energy, and then what is happening? Basically, some of them they are so all of them they are on different technology readiness levels. So let's say if we consider technology readiness level 9, then it says that system is proven in operational environment. So this is what we want. We want the system to be proven in operational environment in real conditions, and we want to show that it actually works. And then let's say if we consider technology readiness level 6, then it just says that, okay, we have maybe verified some simple prototype, some small prototype of the system, and we showed that it works. So basically, we just remember about this technology readiness levels, and then what we see that actually, if we consider different tidal energy technologies, and there are many different like technologies, then we see that all of them, they are on different technology readiness levels. So maybe I will talk only about levels, let's say 9 and 8. So if we talk about technology readiness level 9, so this means that system is actually proven to work. Then there is this barrage technology. So it just means that, okay, we have different levels due to tidal flow. We have different levels of fluid, and then we just have a turbine that tries to harvest energy due to the flow from right to left. So this is very simple technology. Then the second technology is like this horizontal axis turbine. So it's a bit similar to the wind energy, but just a bit clever. So we just have a flow through these blades, and then we just rotate the blades, and we get a bit of energy due to rotation of the blades. So this is technology readiness level 8. So basically, system complete and qualified. So now it just needs to be fully proven in operational environment. If we talk about wave energy, then again, we have many different technologies. And if we talk about technology readiness level 8, so we don't have technology readiness level 9, we have only 8. Then what we see, we have basically this oscillating water column technology. So it just uses, basically we have like some semi-submerged structure, and we have some enclosed air in the structure, and we have a turbine, and then we have waves coming, where we have some change in the pressure in this air chamber, and we basically, this air wants to go up and down, and so we have basically a bit of, we can actually make this turbine to rotate here. So it's actually something like maybe one of the first wave energy technologies that was developed, and it's already on technology readiness level 8. So it's actually proven, it's system complete and qualified. And then another one is an attenuator. So it just, let's say, follows the waves, and due to mechanical load supplied, it actually attenuates the wave. So the obvious example is Pilanes. Maybe you have heard about Pilanes. So this is one of the examples. And then the last one, the last ocean energy group of ocean energy technologies is related to this ocean thermal energy. So actually, sometimes people forget about this ocean thermal energy, but actually it can provide a lot of opportunity. So here what is happening is that we just try to use some evaporation. So basically it works only close to equator. Then we have some considerable changes in the temperature during night and day, and then we have some evaporations that we can use to harvest energy. Okay, so and here these dots, they show the sites in which it actually either working or projected or under construction. So I think that this one relates to either Samoa or Fiji. I actually don't remember. Okay, and then there are also other marine energy types. So let's say offshore wind is also, since it's in marine environment, and it's also marine energy, and then floating solar, something which is getting a lot of momentum currently, and some hybrid solutions, wind, wave, tidal, solar, a lot of different things. Okay, so then basically so this is just an overall overview of marine energy. So now if we talk about the current state of marine energy, then what do we have currently, let's say 2021? So we actually see that, okay, there are many different sites in which we try to use this marine energy. So we use tidal, wave, or tech, so this thermal energy. And actually, they are all around the world, but not in New Zealand. So actually, New Zealand is not even presented here because there is nothing happening in New Zealand yet. But still, if we talk about the actual capacity installed in these plants, it's only 500 megawatts. So obviously, if we compare with the total energy production globally, then this 500 megawatts is nothing. It's nothing. So there is a lot of way for us to go. And actually, if we talk about potential again, then we see that actually only wave, let's say, can generate 29,500 of terawatt hours. So this is, if we compare even to current energy production, then it's of course a lot of power. So again, basically, marine energy has a lot of power potential. We just need to be clever and try to use it. So currently, basically, if we consider tidal energy and wave energy, then we see that, okay, even plant capacity, plant capacity for the tidal is just around 1.5 gigawatt. And the plant capacity for wave energy is it's actually only 100 megawatts. So not so much. So there is a lot of things to do. And actually, this is probably like relevant slide, an important slide. It's just because basically, if we consider, from the market perspective, what is happening in the market. So now we see that actually there is, like, first of all, everywhere in the world, marine energy is getting a bit of momentum. So there is some funding everywhere for marine energy, especially in the States and in the UK. So actually, especially for tidal energy, we get already a bit of market push. So we went from, let's say, R&D and technology development, we went into the stage of market push, at least for tidal, and wave is close. Wave energy is close. So basically, hopefully soon we will get into this rapid stage of increasing the deployment. So this is like basically within the next 5 years, let's say tidal energy, it will be already a reality in countries like China and States and also UK. Wave energy may be a bit lagging, but it will be there soon. Okay, so maybe we'll not talk about specific tidal technologies which are already operating. So basically, let's say there is one in Korea, and the annual generation is 552 gigawatt hour. And another one, what is it, in UK? So basically just 11 gigawatt hour to the grid, and basically the total capacity is 1.2 megawatts. Then also there's another one in Scotland, and also this one, which is already this Atlantis, which is actually kind of, sorry, it's not Atlantis, Orbital Marine, which is working already in Scotland, in the States, and also in Spain. So they are kind of strong, and very soon they actually probably will be generating some money. So basically what I want to say when I show these slides is just I want to say that there are some sites in which this tidal energy is already operating, delivering to the grid. And actually some of the technologies like this orbital marine, they just rapidly growing their presence. So soon they will be not only in Scotland, but not only in Scotland states and in China, but probably everywhere. Okay, so this is now one, and then other tidal energy devices. If we talk about wave energy, then basically there are like again, so some power technologies, power boy, the states, then Carnegie Wave, which is from UK, and also is Echo Wave from Israel. So all of them are slowly getting momentum, but maybe a bit lacking comparing to the tidal energy. And then also Waveswell, which is in Australia. This one also in Australia. And then we have one developer, one strong developer in New Zealand, Aotearoa Wave HL, so Engineering Hydraulics Limited, and we are collaborating with them a lot. So actually they have already deployed and proven in operational environment that their 250 kilowatt device is actually working and delivering. So unfortunately they had to do their testing not in New Zealand, but in the States, because here it's very difficult to get any sort of support. But actually their Aotearoa Wave technology seems to be one of the most promising in terms of wave energy globally. So hopefully we're just getting more momentum, more and more momentum. And then hopefully soon we will also deliver to the grid here in New Zealand. Okay, and then, okay, probably I will skip this one about the thermal energy. So there are also some projects in Hawaii, also in Japan, and then in Tahiti, and also in France. But then if we talk about, so, okay, so this all looks very good, but what about the actual problems and the issues with all this marine energy? So clearly we said that there is a lot of potential. It has some benefit comparing to, let's say, solar and wind, but then what are the issues? What are the issues and why it's not yet there? So basically the idea is that we just need to remember what happened before. So what happened before is like, okay, in 1970, there was some oil crisis. So UK started to invest a lot in marine energy. And then around 1980, there were already 300 devices in development. So everyone thought that it's real, let's just do it. But then actually it turned out that unfortunately, everything is a bit harder than expected. So basically the problem is that basically, if you, let's say, talk about only wave energy, then obviously the environment is very harsh. So basically your device can be very easily destroyed or just overturned and it can very easily made non-operational, let's say. So that's why actually after several deployments, people started to think that it's not real and basically marine energy cannot work. And then slowly we came into this like more mature devices, which actually understand what we're talking about. So we understand that we are actually in these harsh environments. So we need to make our device durable and operational in these environments. And then basically started to develop prototypes, like let's say this orbit marine or this Velo wave energy, which actually operating very nicely and already operational and can deliver what we claim to deliver. Okay, so now if we talk about New Zealand specifically, then obviously there are some issues, unfortunately, that even if we compare with Australia, in Australia there are a lot of funding mechanisms which are specifically for offshore energy and marine energy. So basically in Australia, the government understands that marine energy is the future and they try to invest money in this. But unfortunately here in New Zealand, the political support is quite small. And basically, even if you want to deploy some devices, and this is something that I unfortunately had to face when I was deploying my devices, when I need to face some issues with getting consents. So basically, it's not an easy thing to get your, even if you have developed a device that seems to be working, then putting it into water, it's not an easy process. And also important thing that we need to make Maori and Hapu interested in this, and this is something that I'm working on very, very seriously. And actually, it means that if we don't act now, then we will lose to other countries like UK, Japan, Israel, and of course the States. So actually, currently, we can state that unfortunately, New Zealand is not really participating in developing of marine energy, because even if we talk about EHL, Azura Wave, which is one of the best wave energy devices developed here in New Zealand, then unfortunately it doesn't have support here in New Zealand, but it actually gets support in the States. So in the States, they invest money in this device, in our device. And actually they believe that it will be, it's actually already delivering to the grid in Hawaii. So it's already working in Hawaii. Okay. Yes, and also we need a bit of education in terms of marine energy. So this is something that I try to work on at my department, also trying to maybe have a special master program related to this marine energy. Okay, so I will maybe skip this plan for us, but basically why it can be basically something like an opportunity for New Zealand, this marine energy, why it can be useful. Basically, of course, because we have a lot of coastlines, so basically the coastline is very, very long. And basically we have 9th biggest exclusive economic zone in the world. So a lot of Pacific Ocean is close to New Zealand, and actually a lot of energy potential. So some of the strongest wave and tidal forces. So a lot of energy potential, and also generally New Zealanders are super strong in everything related to marine. So it's a land of navigators and sailors, and basically have vast offshore operational experience. So it's just a big question why we don't want to do anything related to marine energy here in New Zealand, because we have a talent, we have a history of doing marine energy, something in marine space. So why we just don't, why we are missing this opportunity? This is a big question. Okay, so maybe I will just skip this one. So this is how we see how our TS is the future. So we just maybe need to, if we have a proper investment from the government, then we can actually get things going. And just maybe a bit more information about natural advantages in New Zealand. So even if we consider Cook Strait here, when we get, what is it, the average depth average speed is around 2 meters per second. So it's amazing tidal energy potential. So we just need to put some tidal turbines here. Of course, we need to understand, we need to make proper calculations and make sure that it will not have any, it will not affect any, it will not have any harm on the actual fisheries there, but actually this research is already done, and a lot of research in this space is done by CAFRON. And basically it should be possible to put some tidal turbines in Cook Strait and make it work. And also, if we talk about wave energy, then some research has been done on what places in New Zealand can be beneficial, can be advantages for wave energy. And basically, we are talking about, we were considering distance to the power grid, distance to port, and also, of course, wave energy resource. And basically, it seems that even Cargill and also Greymouth, maybe they are super good places for trying to use some wave energy plants to power these places. Okay, so basically, I'm a bit surprised that what happened with these slides. Just 1 second, let me just reopen this. So why these slides are blank? They shouldn't be blank. Just 1 second. Just 1 second. Why these slides became blank? Maybe I'm having some connectivity issues. Just 1 second. I might have some issues with connectivity. Okay, so let just 1 second. In the meantime, if you have questions, then you just go ahead and ask.
Alan, Mark's got a question.
Yeah, Alan, Mark and Dunedin. I'm a plant ecologist, but I've been in discussion with a group in Christchurch, which went by the name of Neptune Energy. And they had a resource consent for a trial prototype in Cook Strait. And they were keen to develop their system of generation, but they needed additional finance and couldn't find it either within New Zealand or elsewhere. So I think the system, the proposal is in jeopardy. They did have a resource consent, and I think that for the lack of additional funding, the proposal has lapsed. But they reckon they could generate in Cook Strait the equivalent amount of energy that's currently being generated in Dunedin. They're currently working out at Bromley, near the coast in Christchurch, generating energy from the sewage from Christchurch and actually injecting carbon dioxide into the system and generating hydrocarbon fuel from that system. The guy's name is Chris Bathurst. He ran Neptune Energy, and he works with a guy called David Beath, who is also working out at Bromley on the sewage system. And I think they were disrupted by one of the recent storms in Christchurch, but those two would be worth contacting in relation to a proposal for Cook Strait with a prototype developed, made from carbon fiber and anchored to the floor of Cook Strait. They said Cook Strait was one of the best sites in the world, 300 meters deep, and the only impediment was migrating whales. They said Provo Strait was too shallow. They were also looking at Tory Channel as a possibility, but their boat movement was a bit of an impediment. But they reckon Cook Strait was one of the best sites, best potential of any site in the world. And they were very disappointed to see it failed for lack of additional funding to improve and it actually put in the prototype and give it a test. And right on the Cook Strait cable, couldn't be better placed for serving the country as a whole. So
Yes, Alan. So
you might benefit from getting a hold of David Beath or Chris Bathurst in Christchurch. Yes. I'll put them in touch with you. If I assume your email address is Vladislav.Sorokin at Auckland university.ac.nz.
Yes, exactly. So I actually put it in the chat, my email address.
Maybe I could add something to that. Vladislav, the Neptune Power 2009, they wanted to put a 1 megawatt turbine in, and if it was successful, they planned to put in 30 turbines that would generate 350 megawatts in Cook Strait.
Yes. So basically, I just want to say that I don't know, is it fortunate or it's not fortunate, but basically now to New Zealand market, we have a real, very, very strong player that is coming to New Zealand market. So there is a company called Aquantis that already has been deploying the device. It's also tidal energy. So actually, this is the turbine. This is the turbine from Aquantis. So they already have been proven to be operational. They have been working in Scotland, then also in Spain, and also in the States, in Florida. And now they actually coming to New Zealand. So they exactly targeting the Cook Strait, exactly why because Alan said that actually Cook Strait is one of the best in the world for harvesting tidal energy. So this company is coming here, and I met with the founder and CEO of this company. So they are very determined to make it real.
And as you said, absolutely reliable, one of the most reliable sources that's available for harnessing.
Yes.
Vladislav, David Painter here in Christchurch. And just to add to what Alan and Peter have said, both Chris Bathurst and David Beach are colleagues of mine. And as Peter alluded to, this work was way back in 2008, 2009. And for the various commercial reasons, they progressed as far as trials in Scotland. And it looked very promising. However, both the commercial aspects and also the competitive aspects of those who currently operate the main parts of the grid, at that time, it didn't go ahead. If there is any benefit to you in being in touch with Chris Bathurst or David Beach, I'm right here on the spot.
Yes, thank you. I think that it definitely will be very, very useful for me to get in touch with them. And also, basically, I think that we have some, so Aotearoa has some good connections with EMEC in Scotland. So I can even just try to contact the people in EMEC and try to find what was actually happening there. So how was the testing? What happened?
Vladislav, it's Peter Whitmore again, and you're probably aware of this, but back in the early 2000s, they were going to put, there was a group called Crest Energy in 2008.
Yes.
They got a consent to put in 100 and then 200 turbines into the Kaipara Harbour.
Yes.
Total capacity 200 megawatts, but the project was dropped in 2013 because of uncertainty about the electricity market. They thought if they put it in, they might not be able to sell anything.
Yes. So basically, obviously, we know about this very unfortunate event with Kaipara Harbour and Crest Energy. So basically, the idea is that, and again, this is something that I'm relatively new in this field, but actually, this is actually how I see everything was going back then. So basically, this Crest Energy, they just one of the most important stakeholders in all this marine energy is actually EV and HAPO. So we need to make sure that they are happy with what is happening with marine resource. So basically, and we have Maori people in our board on our tier, and they, like, from their perspective, it looked like this. So basically, this Crest Energy, they came, and then they actually agreed with only one of the HAPO in this local HAPO. And the other, they don't consult with other people. So they basically just get some money from the government and agreed with some particular HAPO. And then they started to do things. And actually other people with whom we were talking, including Maori, of course, and other HAPO in this area, they were against it. They were against doing this kind of thing because they didn't provide their consent. They didn't agree to these things. And then in the end, obviously, there was too much of this kind of tension, so it didn't work. So this is a big unfortunately, this is like a big problem. So basically, the idea is that unfortunately, if we relate to what I have been talking previously, to this kind of, if we talk about this, like, okay, so we had like peak of expectations around 2008 when we had this Crest Energy. But basically, we were just some guys who just wanted to earn some money quickly, and then basically it didn't work because the technology wasn't ready, and they didn't talk with the right people. And then obviously it failed, and now we're somewhere maybe here. So we're unfortunately somewhere here because it didn't work first time. So this was a bit of a problem. So this is unfortunate that this happened, but that's basically that's life. So we basically, in terms of our tier, we really believe that basically we just need to make sure that there are two main projects. So the first one is this, where is it? EHL, which is testing in the States. So basically this is one of the main, where is it? Yes, EHL. So this is one of the main wave energy developers in the world. So we hope that, okay, once they prove themselves in the States, it will be enough for New Zealand to say, okay, these are our people, and they actually they are the best in the world. How about we just try to give them a chance here in New Zealand? And then the second big hope is that now when we have Aquantis here, and they are really targeting to put the tidal turbine in Cook Strait. So because they have proven that they work in Florida, they have proven that they work in Spain and also in Scotland. So hopefully maybe it will be also real here in New Zealand in Cook Strait. So this is our hope. And also, like, if we talk about what we're trying to do it in our university, in the University of Auckland, then obviously we cannot compete for now with this like big and established companies. So we just try to work on this niche application on trying to power some buoys. So buoys that do environmental monitoring. So we need to understand the quality of the water. We need to understand the wave heights. We need to understand what is happening in the water, potentially taking photos of the water, of the sea life. And these buoys currently they are powered with the solar energy, but this is not really reliable, and many buoys are getting lost. So we just want to try to use wave energy, and we already have several prototypes deployed and tested in the real ocean conditions. So hopefully it will work also. Maybe we're not talking about 5 years from now. We're talking maybe 2 years from now that it will become commercial, because basically we're talking about small buoys that okay, the total weight is around maybe 200 kilos or maybe 100 kilo. So it's very simple to, and the power consumption is maximum maybe 5 watts. So obviously we can deliver this 5 watts using wave energy or marine energy. Yep. So I just want to say that, so personally, I'm not talking about my own perspective. I'm talking about, let's say, our TA perspective, but we believe that now is a good time to start talking about marine energy, because we believe that it will be soon. So basically, it's already becoming real in the world, and we hope that it will also become soon reality here in New Zealand. So because of this Aquantis, tidal energy, and also EHL and by wave energy device. So it's already here. So maybe within this coming couple of years, we'll already make it real.
And Vladislav, it's Doug Wilson here. I was just wondering if I could ask a question in regards to transmission, I suppose, from the energy source. So location between demand and supply. Is there potentially, you've talked about positions that are obviously along the main trunk of Cook Strait, makes a lot of sense. So
yes,
what's the cost per comparisons, and if the differences in how far away it is to get to demand where you need? So where's the sweet spots that really make sense, other than obviously Cook Strait, to get to where the demand is also, so for renewable energy in New Zealand?
Yes, so this is a very good question, because basically, even if we consider globally, then we see that, okay, the device is not, actually, it's only half of the price. So the device itself is only half of the price to get it delivered, because to make it real, because another 50% of the total price is actually these underwater cables and these kind of things. So in New Zealand, basically, there was some research done by a PhD student, and she was working only on this, trying to find good spots for wave energy, because as you said, if we talk about tidal energy, then it's just Cook Strait. And basically Cook Strait seems to be the best, and because they have also this cable and demand, so it's kind of obvious. But in terms of wave energy, she has done a lot of research, and I wasn't involved in this research, but I know the person, and she is very, very capable. And she has published papers in several very good journals. And then she basically showed that so basically this should provided this kind of map. So basically New Zealand case study, optimal wave energy site locations. And then actually if we talk about, she was relating to the known practice, and she was saying that if we talk about more than 60%, then it's already has a lot of potential, so it should work. It's promising from the terms of from the point of view of actual investment and the levelized cost of energy. So she was considering distance to power grid, distance to port, and available wave energy resource. And then she basically obtained that Invercargill is obvious, and also this Greymouth is another obvious choice. So I think that maybe we start. If we talk about wave energy, maybe if EHL will deploy somewhere here, or maybe here, when it will be already, and they prove that they can deliver to the grid, then it will be amazing. So I know that this is one of the current plans, and also like New Climate seems to be not that bad. New Climate seems to be not that bad, and I know that Araake, we're in touch with Araake, which is New Zealand Energy Center, Energy Innovation Center. So they're also very interested in trying to have a trial of this wave energy for supplying to the grid in New Climate. So we hope to have a site close to New Climate in which we will try to deploy some wave energy devices, and they will be delivering to the grid. So basically there are 3 points. So Invercargill and Greymouth, they seem to be optimal from all perspectives, and EHL is planning to target these 2 points, Greymouth and even Cargill. But if we talk about where we get, so to say, joint momentum, where we get joint efforts, where we get some interest from Araake, from MBE, then it's actually this New Climate. New Climate seems to be, because we really try to develop a site for wave energy close to New Climate, and it will deliver to the grid in New Climate. Hopefully this will be done in the near future, if everything goes well.
Can I ask a question about the Aotearoa wave energy device, and what's the operating principle? How does it work?
Yes, so this is a very good question. So actually Aotearoa wave, it seems to be, first time when I have seen it, the operating principle, I was thinking that it shouldn't really work. So it shouldn't really work because it seems to be a bit fragile, So basically what we have something like, maybe I will try to draw it here. So basically what we have is something like this. So we have one thing, like 2, let's say, rods, and in between we have like a bar, and then we have like a huge thing which is rotating. So basically this huge thing is getting pushed by the waves back and forth, and then here we have inside of the main structure, which is shown in yellow, we have actually this hydraulic transmission system that basically transforms motion of this big part, this big black part into energy. So and then the thing is that this big yellow part, it's actually more to the ground, and then so basically the idea is that it's more so this black thing is not moored, so it's basically just freely moves. It moves back and forth. This yellow thing is actually more to the seabed, and then we have some motion of this black thing. We have a bit of motion of this yellow thing, and then in the end, this motion generates a lot of power simply because this black floating part is very, very heavy. So it's very, very heavy. So when it rotates or just oscillates, it provides a lot of energy.
Interesting.
Yes. So actually, when I first have seen it, I was thinking that it shouldn't work. It shouldn't work because it's too fragile. You have to moor it. It's too difficult, and it's a concept that maybe not maybe it's like something, it's not really thought well concept, but in the end, comparing to all other devices, it seems to be one of the best.
And what's the scale of the thing? Each one of those things, does it generate the 250 kilowatts?
Yes, yes, exactly. So for now, we have been testing and successfully tested 100 kilowatt device. And it was, I think it was in Hawaii for 3 years, maybe, as far as I remember. And now we are actually already deploying the next generation, which is 250 kilowatts. So it's one device generates this kind of energy.
And Vladislav, what's the size of that from the top of the yellow to the bottom? What's the size of that platform? The whole.
I think that if we talk about 100 kilowatts, then as far as I remember, the overall height is around 5 to 6 meters, and this one is probably maybe 2 meters. So it's not too large. It's not something which is really a bit exaggerated. So,
okay.
Yep. So personally, another device which is actually kind of interesting is this, and has a lot of potential, is this Velo device. Where is it? Actually, this one that has 30 megawatts India deal, and also in China so basically it's like a boat, and inside of this boat we have like a rotating pendulum, and then due to rocking and swaying and also pitching of this boat and tilting of this boat and swaying of this boat, they have obviously designed it properly, and inside they have like a pendulum which is just rotating, and in the end they get a lot of, so everything is enclosed inside, so all moving parts are enclosed inside, and this generates also a lot of energy. I think it's also around 250 kilowatts one device, and everything is enclosed, so it's very, very robust and it's very, very durable. So one of the devices, actually it's shown, I think it's shown here. So something like this. So here we have like a rotating mass. So we have a boat, and inside of it we have a rotating mass. So heaving and swaying in the waves cause a lot of rotation of this wave, and then it actually generates a lot of power. So this is another device which is definitely viable and already operational and produces to the grid, provides power to the grid.
Vladislav, Stefan Heubeck here, hello. Hey, just one hint when you're talking about the ideal location in New Zealand, if you're talking to Ariake about doing something in Taranaki,
Yes.
Keep in mind that there's already, it's either 11 kilovolt or a 33 kilovolt connection from Taranaki out to the Maui platform. So
Okay.
you're basically several dozen kilometers offshore, and you're in an exclusion zone. The only problem you have is that the noise and the electromagnetic noise you're creating there could interfere with some seismic surveys. But you're basically already in a zone where you can't fish, where recreational, it's too far offshore, and you're really in the middle of nowhere. And you basically have the cable there. You just need to plug in at the platform. And to get test equipment, a megawatt or 5 megawatt in, the cable can definitely take that.
Yes, thank you, Stefan. So this may be exactly why Ariake and MBE were actually interested in having this test site in Taranaki, because it seems to be obvious choice. And so we do hope that it will work, and we are in close contact with Ariake. We hope that it will work out well.
It doesn't look like it's on the map, because it's basically where you have the end of New Plymouth. It's basically directly to the west there. So it's like 20-30 km south of your NP3.
Yes.
It's further off. It's further offshore.
Okay. I see.
So it's not marked here. The Maui platform is further south than any of those three NP1 to 3 spots marked out there. So it's if you have the bottom of the end of New Plymouth, that's where the current gas pipeline lands onshore. That's at Opunake there, and that's where that cable goes out of the platform. So go a bit further to the west with your cursor, and with down, it's roughly there. Yeah.
Okay, understand.
Yeah.
Okay. Yes.
Yeah, but you have
So-
basically your cable connection there. You just need to plug in the platform if they
Yes.
allow you to do that.
Yes. So Araki, they're really serious about this. At least we hope that they're serious, because this is what they seem to be. So hopefully we will get it. We'll get it there. Because there were also some ideas to have this testing site somewhere in Northland, because basically in Northland there is like, it will create some new jobs and basically will attract a bit of this innovators into this Northland. But unfortunately the resource is not really there. So maybe having it close to Taranaki and this platform, as you said, it will be the best solution for this, for like maybe as just as an illustrating thing. So basically you just put your maybe several devices there, and then they're just operating in this close to this site, and or maybe on this site, and then we generate some power to this cable, and this is amazing. So hopefully it will work. Yep.
Vladislav, I was interested to hear some comments before that some of the New Zealand generators have been perhaps blocking some people trying to get tidal or wave generation going in New Zealand. Have you heard of any of the New Zealand generators who are actually looking to partner with tidal or wave energy companies, perhaps overseas, to actually kind of develop that?
Yes, this is a very good question. So for now, we had been in contact with Meridian Energy, because Meridian Energy, we're already collaborating with marine energy developers in Australia, so they're very interested. So Meridian Energy is the first candidate, but also we were talking with North Power, for example, and also with Contact Energy, and they seem to be also, they had some interest. So the idea is that as soon as we basically prove that the device can deliver to the grid here in New Zealand, then I think that they will be on board with us. But again, North Power, for example, they're obviously operating in the Northland, so they're not really, probably not very relevant for this Taranaki region. So maybe Meridian Energy, they're just bigger and they have more experience with this. So basically, thank you very much for inviting me to do this presentation. And basically, you have my contact details, and I will definitely, if you have any questions, then I will be happy to answer. And it's interesting.
Спасибо, добрый. Спасибо, Vladislav.
Thank you.
Добрый.
Thank you.
Thank you.